Bonjour à toutes et à tous. Je suis très heureux de vous accueillir ici aujourd'hui à l'Iliade, à Centrale Lille, pour une demi-journée de workshop sur la construction modulaire, sur la construction lean, sur la construction 4.0 et sur les notions d'infrastructure, de digitalisation à travers le BIM, mais également d'architecture. Je suis vraiment très heureux également d'accueillir trois experts au niveau mondial. Je vais commencer par le plus jeune, Monsieur Ismail Labidi, qui est ici présent, s'il peut se lever, voilà, qui est présent, et Monsieur professeur Tarek Zaïd, qui nous vient de Polytechnic University à Hong Kong, et professeur Mohamed Hussein, qui nous vient de l'Université d'Alberta à Edmonton. Ça sera vraiment une journée d'échange, de partage. Souvent, on va fonctionner 30 minutes de présentation à 3/4 d'heure. Il va y avoir une bonne pause où il y a de rafraîchissement, café, biscuits, chocolat et quelques jus au milieu pour ceux qui n'ont pas encore mangé. Et on est vraiment, je vais jouer le rôle de modérateur ici présent.
Alors, bonjour à toutes et à tous. Je m'appelle Ismail Laribi. Donc, avant de me présenter, je dois quand même dire un grand merci à Monsieur Zubair Lafage pour pour la présentation, pour le mot de bienvenue, pour surtout de nous avoir accueillis à Lille, excellente école, à un grand campus, à une ville qui m'a vraiment impressionné. De formation, je suis ingénieur civil. Je suis aussi ingénieur en géomatique et topographie. Actuellement, je suis le fondateur et le gérant de la société GeoRevos. Donc, c'est une start-up 100% tunisienne et suisse. On est actif dans le monde de géospatial. Nous proposons des services variés dans le domaine de géomatique, donc d'où le nom Geomatic Revolution System, spécialement le BIM, le Digital Twin, qui sera aussi le sujet de notre présentation aujourd'hui. J'espère qu'on va passer une très bonne demi-journée ensemble. Et puis, je pense que j'ai commencé ma présentation. Alors, vers une ville durable, convergence géospatiale, BIM et Digital Twin. Donc aujourd'hui, le jeu spatial, il présente plusieurs technologies, plusieurs atouts. Et parmi ces atouts, c'est ceux que j'ai choisi aujourd'hui de vous présenter qui rentrent parfaitement dans l'industrie 4.0, dans la construction 4.0, qui est le BIM et le Digital Twin. Donc, on va voir ensemble quels sont ces deux domaines et comment surtout on va exploiter ces deux technologies qui révolutionnent aujourd'hui nos manières de travailler dans la maintenance et dans la gestion et efficacité. Donc, pour ma plan de présentation, on va commencer de présenter GeoRevos, donc notre startup. Ensuite, on va commencer à parler du secteur AEC. AEC pour l'architecture, engineering et construction. Quels sont les challenges, quels sont les défis? On va passer à la numérisation, les défis et les avantages de cette numérisation. Et on va finir par présenter le digital twin. Qu'est-ce que c'est un digital twin? Comment on peut avoir un digital twin présentant l'état actuel présent d'un environnement donné? Et surtout, comment exploiter ce digital twin pour le GEM, qui est gestion, exploitement, maintenance. GeoRevo, c'est les pluridisciplinaires. Donc, on a des ingénieurs en construction infrastructure, des ingénieurs civils, des architectes, des ingénieurs CVC, donc dans le but vraiment de pouvoir travailler sur le BIM, mais aussi on a des géomaticiens. Nos travaux comportent tout ce qui est classique, travaux géométriques, la photogrammétrie, la lasergrammétrie. Donc, je ne sais pas si ces deux notions ils sont assez claires pour tout le monde, mais ce sont des technologies de capture de réalité. On a tout ce qui est SIG et mapping, donc les systèmes d'information géographique, GIS, donc GIS System. We provide solutions for our clients with mobile applications and web applications. And the mobile mapping system and AI, donc on utilise la technologie d'intelligence artificielle pour pouvoir détecter des objets automatiquement à travers une simple caméra, qu'elle soit sur un téléphone portable, ou bien une caméra, un système embarqué sur une voiture mobile, ou voir des systèmes de caméras de photogrammétrie, par exemple, ou autres. Donc aujourd'hui, on va plutôt se concentrer sur le BIM Digital Twin. On va définir ce que c'est le BIM Digital Twin, qui est une compétence ou clé de notre service, et surtout parler aussi de virtual reality, VR et AR, donc la réalité virtuelle, la réalité augmentée, ils sont aujourd'hui un atout essentiel dans l'industrie et dans la construction 4.0. Tout ça, en fait, pour tout simplement offrir une palette de solutions, de services qui soit plus ou moins complète et surtout qu'elle soit adaptée aux besoins de nos clients. Un point très essentiel de notre startup, c'est surtout l'investissement dans les nouvelles technologies. On sait qu'aujourd'hui, que le monde évolue, on a cette transition au numérique, cette transition au digital, et puis on a souvent des challenges pour travailler dans ce secteur. Ces challenges qui peuvent être de la résistance, des gens qui résistent au changement, et parfois ils peuvent être tout simplement le manque de compétences ou le manque de formation. Donc le but, c'est vraiment d'avoir un matériel de pointe, des ressources et des compétences clés pour pouvoir résoudre les problématiques de notre marché actuel et surtout de se conformer à la veille technologique pour pouvoir donner de l'avantage, pour pouvoir donner des solutions optimisées pour nos clients. Alors l'industrie 4.0, ça ne se cache pas, aujourd'hui on y est, que ce soit avec l'automatisation, la connectivité, donc on essaie plus ou moins d'automatiser les tâches pour en gagner du temps, gagner en service et de pouvoir partager nos données sur un cloud. Et ce cloud doit être commun. Et avec l'avancement technologique et l'apparence des IoT, Big Data, on va pouvoir gérer une quantité massive de données. Et ces données peuvent être sous plusieurs formes. Donc non seulement des données de construction, ils peuvent être des modèles d'information variés. Et surtout, le problème aujourd'hui, c'est pouvoir gérer toutes ces données et donner une intégration complète dans nos systèmes. Quel est l'apport du jeu spatial dans tout ça? Donc, le jeu spatial, c'est un mot qui est issu de la technologie de géomatique. Donc, c'est un mot grec, géomatique pour géo pour géographie, matique pour l'informatique. Alors, notre travail il repose principalement sur trois éléments essentiels. Tout d'abord, on a la collecte de données, la collecte qui peut être aujourd'hui sous plusieurs formes, que ce soit on va choisir un modèle prêt de données à utiliser, ou bien c'est nous-mêmes qu'on va créer la donnée. Je prends l'exemple en Tunisie, par exemple, contrairement en France. En France, on a toute la donnée, la quasi-totalité de données qui est ouverte via des géoportails communaux. Donc, pour, par exemple, travailler sur un projet de construction ou un nouveau projet de construction, on va tout simplement chercher cette donnée tout simplement dans les géoportails, dans les plans existants, et par la suite, on va faire évoluer notre travail vis-à-vis ces données-là. Dans les pays plutôt africains, ce n'est pas la totalité des pays africains qui disposent de ces données-là déjà prêtes. Donc, on va pouvoir travailler sur la collecte, que ce soit par des satellites, par des drones, par des lasers, pour pouvoir au début collecter une quantité respectueuse de données, ensuite traiter les données via des bases de données sophistiquées, des bases de données géomatiques, c'est pareil aux bases de données dans le domaine d'informatique. Ils sont régis par des règles, par des normes, et au final, on va pouvoir diffuser ces données. Et la diffusion de données, elle peut être que ce soit par des cartes, des plans, listes statistiques, des applications web mapping, des applications web, des web services, ou bien aussi on parle aujourd'hui souvent de BIM et du digital twin. Secteur acteur, donc on fait tous partie du secteur AOC, et ce secteur, il englobe les industries liées à la conception, la planification, la construction, la gestion des infrastructures et les bâtiments. Donc, on a vraiment une multitude d'acteurs, multitude de projets et on a une grande masse de travail à gérer. Pour résumer tous ces challenges, j'ai choisi de les diviser sur 5 parties. Tout d'abord, on a la complexité de projets. Donc, la plupart des cas, on va avoir des projets complexes à travailler, une multitude d'acteurs, des exigences techniques. Ensuite, on a un aspect très important qui est l'aspect du coût et délai. Donc, c'est une contrainte pour chaque projet. Il ne faut pas dépasser le coût de projet et surtout, il ne faut pas dépasser le délai. C'est très important pour pouvoir donner certaine transparence avec nos clients. On vise ce détail qui est très important. Par la suite, on a le changement en conception. On va voir comment, via le BIM, on va pouvoir rebondir ce changement bruscuel au moment de réalisation de projet, au moment de chantier, pour pouvoir anticiper les risques, parce qu'on peut avoir dans un chantier plusieurs risques, que ce soit des risques humains, des risques de retard, ou bien aussi des risques matériels ou des accidents. La troisième chose, donc c'est un point très important aussi, qui est la main-d'œuvre, qui est les ressources humaines. Donc aujourd'hui, rien qui se cache, on a quand même une pénurie de personnel à l'échelle internationale. Donc il faut savoir gérer son personnel, savoir gérer le retard, les absences, pour pouvoir gérer, disons, la complexité de projet. Et aussi, on a ce qu'on appelle la dispersion géographique. Souvent, nos clients, ils n'est pas toujours à côté de nous. Donc, on doit toujours rester en contact et prouver un certain professionnel dans la gestion de projet. Après, on a la partie de gestion et réglementation. Donc, on sait dans chaque pays, il y a une réglementation spécifique. Par exemple, dans le monde de BIM, il y a la norme ISO 19650 qui régit à l'échelle européenne, internationale le BIM, mais il y a aussi le Building Smart international qui a pris en compte les chapitres de chaque pays. On a un chapitre français, chapitre suisse, chapitre canadien, conformément aux réglementations de construction et de code des travaux publics en vigueur. Par la suite, on a tout ce qui est question de durabilité de projet. C'est bien de construire, mais il faut pouvoir maintenir notre projet dans le temps. Il faut pouvoir maintenir et bien exploiter surtout notre construction. Donc, il faut toujours penser à l'impact environnemental, au lean, en construction durable et surtout à l'efficacité énergétique qui est aujourd'hui un sujet d'actualité. Donc, toute cette complexité, tous ces challenges nécessitent forcément l'adoption des nouvelles technologies. Avec la nouvelle technologie, donc c'est bien de l'adopter, mais il faut aussi se former à ces nouvelles technologies. Donc on assure la formation de nos personnels et on essaie d'être toujours à la pointe d'avancement technologique. Amélioration de la collaboration et de communication. C'est bien de travailler sur un projet, mais le plus important, c'est pouvoir communiquer quotidiennement les informations sur l'évolution du marché. Je reviens sur le terme construction 4.0 et l'apport de NTIC et géospatial. NTIC, c'est les technologies d'information, c'est les nouvelles technologies d'information et de communication. On entend parler du BIM, de réalité virtuelle, l'analyse de données et d'intelligence artificielle surtout, la partie sur la capture de réalité avec le drone laser scan, les capteurs et IoT, et surtout de pouvoir faire le monitoring et la surveillance en temps réel de nos chantiers. Donc, toutes ces technologies, si elle est bien choisie, si elle est bien adoptée dans le projet, elle va nous permettre d'optimiser les ressources et surtout de réduire le coût et le temps de réalisation de projet. On va voir par la suite un exemple concret. Effective management de projet, donc la gestion effective des projets, c'est-à-dire on va travailler tous ensemble dans le but de réduire les risques de projet, dans le but de fournir des meilleurs résultats, des meilleurs outputs, dans le but d'optimiser le temps et d'optimiser le coût de projet. On va utiliser toute cette palette de technologies, à savoir la réalité augmentée, l'utilisation des systèmes mobiles, parce qu'aujourd'hui, le mobile est à notre quotidien. Qui d'entre nous n'utilise pas son téléphone quasi-totalité de son journée? Donc, nous proposons des solutions aussi simples à utiliser par téléphone portable. Je vous laisse avec une petite vidéo sur le Digital Twin pour voir une image claire sur ce que c'est. Ainsi, le digital twin, il est tout simplement, si on veut le décrire en une équation simple, c'est le BIM avec laquelle on rajoute le IoT. Je ne sais pas si vous avez déjà une idée sur les capteurs IoT. Ce sont des capteurs qui vont nous permettre d'avoir des informations en temps réel sur tout ce qui est components, c'est-à-dire sur tout ce qui est les éléments auxquels on veut avoir une information. Donc, le BIM, ce n'est pas de la 3D, ce n'est pas un outil, ce n'est pas Revit, ce n'est pas ArchiCAD, c'est plutôt tout un process de gestion et de collaboration. On dit souvent, le BIM, c'est 3C. Et c'est collaboration, communication et coordination. Donc, le but, c'est toujours d'avoir un seul modèle via tous les intervenants, les parties prenantes de projet, pouvoir se connecter tous ensemble, travailler tous ensemble sur le même projet, depuis la première phase qui est la conception jusqu'à sa construction et par la suite l'exploitation et maintenance. Si on en compare au CAD, au BIM, on va dépenser plus de temps au début dans la conception, c'est-à-dire on va mettre de 50 à 80% du temps nécessaire pour le projet, pour définir des responsabilités, pour définir des objectifs clairs, qui fait quoi, à quel moment, qui est le responsable de tel rendu et quoi rentre à quel moment. Contrairement à ce que les gens aujourd'hui euh, définissent ou adoptent le BIM comme une 3D tout simplement pour le visuel ou pour tout simplement avoir un modèle qui est joli, qui présente une certaine réalité. Donc c'est vraiment, le BIM, c'est plus l'information qui est très importante dans notre modèle. Les avantages qu'on va avoir par rapport au travail traditionnel, c'est tout d'abord avoir un recours au CDE. Donc on va avoir une Common Data Environment, un serveur commun entre toutes les parties prenantes. Et dans ce serveur, on va mettre toutes les informations sur le projet. Donc non seulement le format natif, qui peut être n'importe quel format de logiciel, Revit, ArchiCAD ou autre, mais aussi on va mettre des informations sur le bâtiment. Ils peuvent être des plans directeurs, ils peuvent être des plans de maintenance, de gestion d'exploitation, et ça va éviter le double travail. Ça va surtout assurer la pérennité de données dans le temps. Mais comment réellement on va faire tout ça et pourquoi devrait-on-nous choisir le BIM? Il y a plusieurs questions qui se posent. Est-ce qu'on utilise le BIM pour une nouvelle construction, pour une construction qui est déjà existante, pour faire la réhabilitation, la rénovation des bâtiments, ou bien on utilise le BIM seulement pour les grands projets et pas les petits projets? Donc, je vous dis la réponse. Le BIM, il est important et il est nécessaire pour tous les projets parce que c'est un processus de collaboration et de communication, de coordination. Donc, le but, ce n'est pas vraiment d'avoir un modèle qui est joli, qu'on va essayer tout au long du projet de partager entre une partie prenante et une autre, mais plutôt d'avoir un modèle commun, un modèle complet qui définit clairement les besoins de projet et qu'on va pouvoir résoudre des problèmes. Donc, on entend souvent parler de LED, LOI. Aujourd'hui, avec la nouvelle norme Building Smart Standards, we have LOIN. Donc, tout ça, c'est des définitions. Mais ce qu'il faut garder dans la tête, qu'il y a deux choses. Il y a un niveau géométrique, c'est-à-dire un niveau de 3D qu'il faut créer. Mais de l'autre côté, il y a un niveau d'information demandé. Donc, Level of Information Need. Donc, c'est le niveau d'information demandé dans le projet auquel il faut respecter et il faut toujours se référer aux normes et aux standards de chaque pays. C'est-à-dire, si aujourd'hui j'ai un travail en France, je vais travailler avec les normes françaises. Et si j'ai un travail en Suisse, je ne peux pas quand même ramener la norme européenne ou seulement française pour régler le problème. Parce que la norme en construction et en travaux publics, elle est différente d'un pays à un autre. Dans le BIM, il y a plusieurs dimensions. On a parlé de 3D. Il faut savoir qu'au début, on va passer quand même par la 2D. Donc, il y a ce qu'on appelle un niveau de maturité. Le niveau de maturité, il diffère d'un projet à un autre. Pour faire simple, aujourd'hui, on parle plus d'efficacité énergétique, on parle de zéro carbone, on parle de zéro déchet, Donc, tout ça, c'est des nouvelles dimensions dans le BIM. C'est le 8D, 9D, 10D. Donc, tout ce qui est lean management, manufacturing, safety, sécurité. Mais en France, on va voir par la suite les chiffres. On est plutôt dans la 5D, 6D. Donc, on a su quand même passer la 3D, 4D, 5D pour aller dans la gestion, exploitation, maintenance. La plupart des projets euh, dans le BIM nécessitent une réflexion au départ du projet. C'est-à-dire, on va avoir plus de marge de manœuvre au départ parce qu'on va mettre plus de temps pour pouvoir gérer efficacement le projet. Contrairement à la planification traditionnelle, parce que dans la planification traditionnelle, on va mettre plus de temps pour exécuter le projet. Et dans l'exécution, on va avoir moins de marge de manœuvre pour corriger. Et par la suite, si on compare à l'utilisation et à l'exploitation du bâtiment, on va voir que les coûts de modification, si on utilise la planification traditionnelle, ils vont être beaucoup plus grands. Comme on peut voir dans le graphique, au début, le graphique en vert qui est la planification BIM, on met plus de temps grâce à un modèle différé de données partagées entre les parties prenantes. Et on a la marge de manœuvre qui est encore bonne, contrairement si on passe à l'étape de l'utilisation, dans laquelle on a moins de marge de manœuvre et dans laquelle on n'a pas droit à l'erreur. Donc, il faut découvrir les problèmes à la main. On va regrouper tous les disciplinaires du métier, toutes les parties prenantes pour pouvoir gérer efficacement le projet. Et si on part dans une construction, peuvent être architectes, CVC, structure, infrastructure, mais on sait tous qu'il y a plein d'autres intervenants dans le marché. Ça, c'est des chiffres de 2021 de top 7 pays dans l'adoption du BIM. Donc, tout d'abord, on trouve l'UK, donc c'est l'Angleterre, avec the most common BIM level. Donc, on part de niveau 2 de BIM. On a dit qu'au niveau 2, c'est plutôt 3D, 4D, 5D. On voit la France qui est en quatrième ranking. La France, aujourd'hui, on part de niveau 2. Donc, on est quand même dans la 4D, 5D dans nos projets. Et le pourcentage des entreprises, disons, ils présentent 35% au real estate, c'est-à-dire les promoteurs ou la promotion immobilière, et le reste, 50-60% pour la construction compagnie, c'est-à-dire les entreprises de services, les entreprises de construction. Donc, on a pas mal d'adoption de BIM. Ces chiffres-là, ils doivent être quand même augmentés de quelques pourcents, parce que ça, c'était en 2021, aujourd'hui en 2024. Donc, on sait qu'aujourd'hui, le BIM, c'est une nécessité et ce n'est pas un choix. Si vous voulez plus d'informations, il y a le plan BIM en France 2022, que vous pouvez le voir, dans lequel on peut trouver des outils mis à disposition par l'État. Donc, il y a le RELI, qui est un outil d'accompagnement à la rédaction des cahiers de charges BIM. Il y a Pratiquer le BIM, c'est une plateforme qui permet d'offrir des formations de logiciels BIM. Donc, il y a toujours un point de départ et ceci peut être un point de départ pour ceux qui sont intéressés du BIM en France. Maintenant, je vais passer au modèle 3D urbain. On entend parler de CIM, City Information Modeling. Donc, on va plutôt présenter plusieurs bâtiments dans un environnement donné. Et ces plusieurs bâtiments, le point de départ, c'est d'avoir une planification urbaine totale sur la totalité des bâtiments. Et par la suite, selon le besoin, on va créer des digital twins séparés de chaque bâtiment pour par la suite pouvoir les regrouper ensemble et avoir toute une information sur un territoire donné. La plupart des gens, ils confondent le SIG, qui est le GIS 3D, avec le CIM. Ce n'est pas la même chose. Quand on parle de BIM et surtout de Digital Twin, de modèle 3D de cité, gardez dans l'esprit qu'il y a plus d'informations demandées à partir de ce modèle. Contrairement au SIG, qui va tout simplement montrer des informations classiques, telles que la géométrie 3D, l'élévation en Z, mais aussi d'autres informations sur la répartition spatiale de ces bâtiments. Donc, on va essayer de visualiser, communiquer des données à l'avance, essayer de faire des simulations et modélisation pour, par exemple, pouvoir gérer certaines problématiques territoriales, à savoir les problématiques de mobilité, problématiques de déchets, problématiques d'émissions carbone, pour pouvoir anticiper les gestions des catastrophes, planifier et gérer catastrophes naturelles aussi. Donc, il y a toute une partie de dangers naturels à respecter, mais aussi le développement immobilier, parce qu'aujourd'hui, on sait qu'il y a une pénurie de logements, il y a des problèmes liés à l'immobilier. Et il y a aussi ce qu'on appelle des friches industrielles. Donc, même les industries, ils rencontrent du mal à continuer leurs services. Donc, on doit quand même réfléchir au développement industriel, comment bien gérer ces sites industriels en question. Use case, donc le digital twin, on l'utilise quasi partout, comme on l'a vu dans la vidéo, que ce soit pour les building infrastructure, donc les bâtiments, l'infrastructure, les routes et les cités. Et l'une des services qu'on propose, c'est vraiment la capture de réalité qui va nous permettre d'avoir un point de départ, d'avoir une idée en 3D, en nuage de points. C'est ce qu'on appelle le produit de capture de réalité de l'environnement pour pouvoir transformer par la suite ces nuages de points en modèles 3D qui peuvent être tout simplement en modèle 3D du bâtiment ou modèle 3D urbain. La plupart des gens me proposent la question, est-ce qu'on utilise ces outils seulement dans la partie de réhabilitation, par exemple des bâtiments, la rénovation des bâtiments, ou bien on peut quand même utiliser cette technologie dans l'exécution de projets ou voire à l'avant-projet? La réponse c'est, on utilise cette technologie dans toutes les phases de projet. Il est possible d'utiliser dans toutes les phases. Je prends l'exemple dans la partie exécution, on doit quand même s'assurer que l'exécution elle est faite conformément au plan d'architecture, au plan de génie civil. C'est vrai d'avoir un modèle BIM, mais il faut quand même le contrôler sur terrain par la suite. On ne sait pas qui va construire, donc c'est vrai qu'on a quand même une certaine confiance, mais si on veut faire les choses correctement, on devrait faire un contrôle quotidien sur tout ce qui est construit. C'est ça le but de capture de réalité. Il y a bien évidemment plusieurs utilisations. Par exemple, je prends le cas du patrimoine pour conserver un patrimoine donné, pour faire la réhabilitation et autres. Je ne vais pas perdre plus de temps sur ça. Il y a certains pays qui ont adopté à l'avance le Digital Twin. Je prends l'exemple de l'Islande, l'exemple de Singapour, qui ont aujourd'hui une plateforme en ligne. Vous pouvez aller checker si vous êtes intéressé, qui propose un Digital Twin complet du pays. Donc ça, c'est un but aussi qu'on réfléchit, qu'on essaie d'accompagner déjà nos entreprises dans le développement de leur propre plateforme qui propose des 3D de leurs projets avec une répartition ou dispersion spatiale complète sur le monde. Par exemple, aujourd'hui, on travaille avec des clients au Canada, des clients en France, des clients en Suisse, voire des clients en Afrique. Et le but, c'est de fournir une idée globale sur l'avancement de leurs projets, sur l'évolution de leurs projets via des plateformes qui sont anonymes et des plateformes qui sont partagées avec eux. Vu que c'est un workshop, donc j'ai voulu quand même passer un peu de temps à un cas pratique. Ça, c'est un projet qu'on a travaillé à Toulouse. Et le projet consiste à réaliser un digital twin de 10 hectares d'un campus universitaire de Toulouse. Puisqu'on est dans un campus aujourd'hui, j'ai choisi ce projet-là. Donc, le mandat consiste tout d'abord à une partie de capture de réalité, tout ce qui est relevé intérieur et extérieur de l'ensemble du site. Par la suite, on devrait fournir un nuage de points complet et ensuite développer une maquette numérique. Ça, j'ai mis LOT 500, LOI 300. LOT 500, c'est vraiment le maximum de géométrie possible qu'on peut avoir, ce qu'on peut voir avec l'œil nu. Et LOI 300, c'est vraiment des informations sur la géométrie, mais aussi des informations sur les fournisseurs. Ils nous ont demandé l'information de fournisseurs de chaque élément dans le bâtiment. Par exemple, si je prends l'exemple d'une porte, on devra quand même mettre qui est le fournisseur de coude de porte dans le projet. Alors, on a travaillé sur un processus BIM. Tout d'abord, on a commencé par le relevé. Le relevé, il était réalisé par drone, par un outil de laser scan. Via ces deux outils-là, on a eu un nuage de points en 3D complet et des photos 360 réalistes. Donc, on peut naviguer à l'intérieur du nuage de points. On peut naviguer à l'intérieur des photos 360 pour détecter les objets et pour surtout avoir une vision complète sur l'environnement avant de commencer la modélisation. Il faut savoir qu'on a partagé toutes ces données-là au moment de réaliser la capture de réalité sur terrain. C'est-à-dire le client, il était avec nous, on partageait le data via un serveur au moment de réaliser la capture. C'est-à-dire au moment où on va trouver un manque ou peut-être une problématique sur terrain, il peut nous signaler ou peut-être prenez ce détail-là ou je n'ai besoin de l'autre détail, vous ne l'avez pas pris sur terrain. Donc ça évite de retourner sur le chantier et ça permet d'optimiser les ressources et surtout le temps et le coût. Maintenant, la partie modélisation, j'ai pris l'exemple, petite partie au sous-sol. Donc, vous pouvez voir qu'on a qu'à partir des photos 360. Donc, vous avez le choix soit de le faire en couleur ou noir et blanc. Tout dépend du temps, de réalisation du projet. Ensuite, on a développé la maquette numérique via le nuage de points. La maquette, elle comporte les éléments CVC, comme vous pouvez le voir, mais aussi l'architecture du bâtiment. Donc, c'est vraiment tous les éléments nécessaires dans le bâtiment. C'est non seulement la forme, mais aussi des informations. C'est ce qu'on appelle le BIM tel que construit, le BIM as built. C'est vraiment ça. Maintenant, pour pouvoir exploiter tout le potentiel du BIM et du Digital Twin, il est important d'avoir une plateforme commune d'échange, de collaboration tout au long du projet. Ça, c'est l'exemple de Revisto, qui est une plateforme de gestion des projets BIM et dans laquelle on a pu échanger tout au long du projet avec toutes les parties prenantes. Donc, il y a le maître d'ouvrage, il y a toutes les parties prenantes des architectes, des ingénieurs civils, responsables de projet, parce qu'il y avait une démolition de 2 blocs. Donc, on avait une contrainte de démolition de 2 blocs avant le commencement du projet. Donc, toutes ces contraintes-là, toutes ces remarques, on peut le garder. Contrairement à la planification traditionnelle, souvent on perd, on a vu avant la marge de manœuvre, et en passant d'une phase à une autre projet, on perd de données. Donc c'est ça l'objectif, c'est vraiment de garder un historique de toutes les remarques, un historique de données partagé entre toutes les parties prenantes. Et pour finir, je reviens sur la question de choix ou nécessité. Donc aujourd'hui, on sait qu'environ 39% de toute émission CO2 elle est due à construction. On sait que 80% de coûts de construction il est utilisé pour l'exploitation et maintenance. Donc on met plus d'argent pour pouvoir exploiter et maintenir le bâtiment dans le temps. Et on a une évolution massive technologique, à savoir le lean, blockchain, comme on va voir avec les prochains intervenants, l'IA. Donc l'adoption de ces nouvelles technologies, elle est vraiment nécessaire pour continuer, pour pouvoir suivre les normes et les pratiques internationales et nationales. Merci pour votre attention.
Merci beaucoup. On peut avoir une ou deux questions parce que dans tous les cas, une fois que les trois conférenciers ont donné leur représentation, il va y avoir une petite table ronde pour poser des questions à tout le monde. Comme ça, on aura le temps encore de poser une question. Est-ce qu'il y a une ou deux questions? Assia, tu es prête là au cas où il y a quelqu'un qui... Est-ce que tu peux te lever comme ça, tout le monde te voit, Assia? Merci, Assia.
Exemple Charot, en fait, je suis professeur émérite à l'Université de Lille et j'ai travaillé longtemps dans le domaine du génie civil et de la Smart City. Merci bien pour la présentation. On voit tout le potentiel de, du jumeau numérique. Ça se développe, on voit qu'effectivement, un peu partout, on parle de ça. Et il y a des grands besoins et surtout de l'avenir. Moi, du fait qu'on est à l'université, on est dans le domaine de la recherche et que vous travaillez sur des très grands projets. Ma question, c'est quels sont les besoins aujourd'hui en termes de recherche pour aller vers des très grands projets de jumeaux numériques?
Une excellente question, surtout avec ce qui se passe aujourd'hui avec l'évolution technologique. Je pense que la recherche va être plus sur le lean, sur le développement de solutions qui respectent les contraintes environnementales, qui respectent surtout l'efficacité énergétique. Et aussi, il y a une partie de tout ce qui est AI et automatisation du travail. Donc, ce que vous voyez, c'est des projets qu'on a réalisés dans des durées qui ne dépassent pas les 3 mois. C'est-à-dire, il y avait 6 blocs de bâtiments. Chaque bâtiment faisait minimum 3000 m² de surface sur 4 étages, 5 étages. Je vous laisse imaginer la quantité de travail, surtout avec le niveau d'information demandé. Donc, on avait derrière une partie d'automatisation. Donc, il y avait une partie qui a été réalisée moitié manuelle et une partie 100% automatique par l'intelligence artificielle. C'est pour cela qu'on dédie déjà 2 personnes dans notre startup pour faire de la recherche et pour poursuivre l'évolution technologique. C'est vraiment très important la recherche dans notre domaine.
Merci. Juste pour vous présenter, le professeur Issam Charo, c'est un spécialiste des Smart Cities au niveau mondial et également il est l'ancien vice-président recherche de l'Université de Lille.
Bonjour. Ah, d'accord. Ok. Donc, je suis imagerie, architecte et conseillère en pratique intégrée pour la construction 4.0. Donc, je travaille sur le BIM, le Lean et toutes les pratiques collaboratives pour intégrer des processus comme le DFMA et le BIM VDC dans le développement des projets de construction. Merci beaucoup pour votre présentation. Ça parle donc essentiellement de données digitales. Je voudrais savoir, avec toutes les technologies justement que vous rassemblez, on ne va pas aller jusqu'au logiciel, mais la question de cycle de vie de la donnée, justement de la donnée numérique et de l'interopérabilité entre les différentes plateformes. Comment est-ce que vous gérez ça? Est-ce que c'est un niveau un peu secret? Parce que j'imagine que c'est de toute façon peut-être une manière sensible, puis c'est tellement pointu ce que vous faites, donc vous avez peut-être des solutions qui ne sont pas encore partageables. Mais quelles solutions vous adoptez et quel temps de développement vous accordez à cette question? Merci.
D'accord. Merci pour votre question.
Merci.
On va parler un petit peu technique par rapport à l'interopérabilité. Donc, il y a deux choses. Il y a deux clients. Il y a un client qui veut 100% de sécurité sur ses données. Donc, là, le partage va être fait d'une manière différente. On ne va pas utiliser le classique, c'est-à-dire les plateformes fournies par des solutions comme Revisto, BIMTrack ou autres. Donc, on a utilisé une fois au Canada Dark Web pour travailler sur une prison. C'est-à-dire toutes les données sont chiffrées. Même nous, donc il y avait aussi blockchain, même nous, on n'avait pas accès. C'est-à-dire, dès qu'on partage la donnée, on perd chez nous. On ne va pas l'avoir une deuxième fois. Et s'il y a une modification, on va redemander la donnée. Aujourd'hui, ce qui se passe avec l'interopérabilité classique, le partage classique, il y a les formats IFC, ce sont des formats d'échange de données. Donc, on parle plutôt de l'open BIM, le BIM ouvert. Et cet open BIM, il va nous permettre d'assurer ce qu'on appelle la pérennité de données. C'est-à-dire, on va se dissocier des formats natifs de logiciels, à savoir Revit, Archicad ou autre, pour pouvoir fournir un schéma de données lisible, mais surtout durable dans le temps. C'est-à-dire, le lendemain, Autodesk, elle veut effacer Revit, je veux quand même garder mes données. Donc, c'est très important cette question d'interopérabilité et échange pour pouvoir assurer la pérennité de données.
Merci beaucoup. On applaudit Ismail. Ismail, il est ingénieur civil à l'École polytechnique fédérale de Lausanne et il a également un master BIM en Espagne, à l'École polytechnique de Madrid. Merci. Maintenant, on passe au professeur, professeur Tariq Zaid. So please, Professor, can you present yourself some minutes? And the talk will be in English. So wake up mainly for my students. It will be great for you. Thank you. Merci beaucoup, Professor Tarek. And please, can you present yourself and you can begin your talk. Merci.
Is my voice come to everybody?
Yes.
So I don't need a microphone, so I don't like it. Okay. Thank you so much, Professor Lafaj, for inviting us actually here. And thank you for all of you who actually attend over here. I'm sorry I cannot speak in English, but the maximum I can do is I say, je m'appelle Tarek Zayed, j'ai professeur à Hong Kong Polytechnique Université, okay? Sorry for that. So this is the maximum I can do for now. I'm always also teasing my young child when I say, hey, the maximum I can do in French, je m'appelle Tarek or je suis à la maison. So yeah, so, but I'm learning and it will be coming. Okay, my name is Tarek Zayed. I'm a professor at the Hong Kong Polytechnic University. I studied my PhD and worked in the US and Canada for 20 years. Then I moved 7 years ago to Hong Kong. I'm working usually on construction engineering management and infrastructure management. So when I looked at the life cycle of a project, you will find design and construction will take 2 to 3 years. Then operation will take 50 to 100 years. So all of us in construction 4.0 and all of them are focusing on the 2-3 years and we forget totally about the 50 to 100 years. So I divide my work on both of them, the 3 years and also the 50 to 100 years. So I worked also 30% or 33% and 67% in both of them. Most of my work actually lies on the construction 4.0 and might be in the future will be construction 5.0 or industry 5.0, where everything is automated and also try to facilitate decision-making tools. So without any further views, these are some of the areas which I am interested and usually focusing and working on. Today, we're going to open this gate only. MIC here stands for modular integrated construction, and this is how they call it in Hong Kong. Modular construction, which is worldwide, and they add the integrated here, the integration of many disciplines together. So as they call it, modular integrated construction and robotics. I'm just a new person in this area. I will show you what we are doing right now. So I'm also working on sustainability, carbon neutrality, carbon footprint, assessing the sustainability of buildings, energy, water consumption, all waste, and all these kind of things. So we have a lot of work on this. Working also on infrastructure management, as you can see, after building a bridge or building a building like this, then you have to maintain. When to take the decision to repair, make minor repair, major repair, or take a decision to demolish, or rebuild, or replace. All these are very important decisions, this decision tool. So the importance of the work that I'm doing is complementing what Ismail is doing. So he is preparing data. I took this data and make a decision-making models and tools out of this. So this is how can we complement each other. So bridge management, we worked on bridge management and a very deep, many people, many students working actually bridge management from the perspective of assessment, inspection using top-notch technology. So technology is always available over there on the shelf, but how can you interpret the results of such technology, make informed decision for the decision maker to take a very wise decision. So this is what we are trying to do. So I make a link between technology and decision making. So we did, I will show you also something. If you need, all these are gates where we can open, then you'll find a lot of work under each one of them. Bridge management, tunnel management as well, same thing. Inspection using different technologies, leak detection for water leak. And this is also a big problem worldwide. So we have a lot of modeling models and also decision-making tools we did for leak detection. Sewer management, also even water networks. We did a lot of work on water networks in terms of assessing the condition, deterioration, replacement decisions, risk assessment, a lot of queries. So if you would like a question, we can open any of these gates and then discuss what we've done. Sewer management, same sewer networks, underground infrastructure management systems for the 3 municipal water networks, water, sewer, roads. So we have also some people working on the roads as well. And then social infrastructure, which I call it social infrastructure for schools, hospitals, and big structures that are available among us. These are the things. So we're gonna only just focus today about this, which is what we are doing in MIC and robotics. Those are the 5 areas. Is my English okay for everybody? Yes. Okay. So because usually sometimes when I get in the middle, be fast. When you find myself talking a bit fast, you just stop me. Okay. Okay. So I will start speaking French. So now, so the first point which I would like to point out, and what I'm gonna do today is just highlights, because there are a lot of things to speak about in each one of them. So we're gonna talk about logistics for modular construction. So modular construction, particularly in Hong Kong, is a high-rise buildings, concrete or steel. You're gonna find 60 stories, which is different from US and Canada, where you have multiple stories, like 2-3 stories, and maximum maybe 10 stories or so in concrete. Those guys actually, they need actually special designers for connections and for concrete structures and also steel. And how can you do that actually in Hong Kong? Because Hong Kong is very a small area where you find the roads are very narrow as well. The lanes are smaller than usual. So trucks, how can trucks move? And how can you do all the logistics is very important. So we developed something for logistics. Also, how can, if we have a project and we need more than 1 tower crane or 1 tower crane So where could we locate or allocate the tower crane in order to achieve minimum time, minimum cost, maximum safety, and also achieve all the project objectives? So this is how can we look at it. We looked at also optimum site layout location for the tower crane. And we also developed for the crane itself, it has some safety issues which we have to look at. So the crane, how can we have a safe tower crane work? So we looked at many technologies, and we are working on developing right now a real-time crane safety monitoring system, which will be very good. And we are approaching automation. So Professor Hatch actually was ahead of us on this issue. We're working on the tower crane. We are coming also to help on this domain. Then the fourth point, which is optimal module lifting, which is how can I make the construction plan more optimum? Because how can you select the location? And based on this location, the different modules will be in different location, and we call it non-stationary construction operation. Because every module has its own cycle. You do not have repetitive cycle. So how can you allocate this in a very good management way? This is what we do actually. And finally, we developed also some technologies in our lab for life cycle module health monitoring, where it will help the decision maker during transportation to check whether the modules has some damages or defects. And then during installation also, if there are any defects. And then during operation, we can use it also to help the facility management or managers to take also some important decision. It will be lifelong for the entire project. So let me go a bit fast on those 5 points. Before I start, modular construction, these are just reminding all of you that modular construction has all these advantages, which I can see the entire industry right now is approaching the modular construction. And previously we were saying the construction industry is when you have the contractor is moving from one project to the other. As opposed to the industry, the factory is fixed and you make the product will be distributed to all the clients. Right now, or the construction discipline, the contractor of the factory is mobile, where the contractor will be mobile to go into the construction site. However, right now with modular construction, we are going to mimic the manufacturing, where we have a factory to produce modules, and then we carry these modules using trucks to the location where you can be. Dr. Mohammed Hussein did actually a 10-story building in New York in 1 week, right? Am I right? Or less than that, maybe, or five buildings, 3 stories. Okay, so it will be like very fast, but the preparation before that is different. Procurement methods will be totally different, and you have to be looking at different trades and different contracting techniques. But anyway, it saves time for sure, and we have a lot of statistics about this. It saves. In terms of cost, it's not totally known that it saves a lot of cost, but in some projects it saves some cost. And also it is safe, sustainable, high quality, because you do that in the factory, it will be a very good environment. When winter, all these kind of things will not impact much. So it is a bit better and faster operation. It has a lot of advantages for the modular construction. I know that all of you know all these kind of things, so I'm not going to stop much over here. I will start with the first one, where we talk about optimum logistics. So what we've done, we looked at the different types of logistics where you can transport all the modules, as you can see on the truck, using trucks, roads, or using sea or ships, where you can put all the modules on a ship, and then you this will be cheaper, but might be not that fast. But this has to be planned very well in advance. So we developed based on both of them using AI technology, GIS, and simulations and some other modeling techniques. How can we make this logistics optimum with minimum cost, minimum time, and safe sustainability as well? We take sustainability into account. So we took all of them into account. So how we looked at, I'm going to show you only just 2 case studies in Hong Kong. Those are our 17th floor, each one of them, and each one will use 2 tower cranes. So one of them will have some temporary storage. In Hong Kong, everything is very, very congested, very small. So to have a temporary storage area is a privilege. It's not to everybody. Some of them will be just in time. So you have to deliver the module the time that you need it. This is impossible actually in construction to a great extent, but this is what they try to do. Those two case studies, we looked at them. We developed some key performance indicators for the different operations. For example, production in the construction site. Check it. Oh, this is supposed to be a video. How can we make this work? Huh? This one. Yeah. Oh, it has to be like that. Oh, okay. So this shows you actually these are some. Oh, it doesn't work. It's supposed to work like this. Some of the features do not work on the it depends on the. Oh, okay. Leave it this way. So these are some key performance indicators for production during the factory. So you have several indicators for you as a decision maker to know, and it shows you the time, the inventory, all these kind of things. I'm not going to stop much here because of time limitation. Same thing for logistics. We looked at logistics, we looked at its cost, the transportation, and also it is. Oh. So you can see it in front of you per day, per hour, per whatever you decide on. So these are all simulations. Construction, same thing. So you can have the cost, the components, you can select what type of KPIs you need, and then you can have it this for decision maker. And this also based on the GIS. It will show you to you in real time where are the tracks and which type of track or which number, and how can you follow up with what's going on. Some of them actually, particularly in Hong Kong, they have to build this in China and then mobilize this to Hong Kong. So you have to go through custom, and in custom you have to have several operations. So you can see like ants. So it's starting from the location where it manufactured at, and then it goes all the way around. For both of them on the sea, you can see that also on the shipping and on the road. So you can see both of them. Oh, it has to be one at a time. No problem. So this one was for this is real time, in real time. So this one for the roads, and this one for the shipping. As you can see, the ship will go right now on this actually, here is a ship, carries all the information that goes in the route that is required. Okay, these are decision-making tools with visual tools and simulations that will help decision maker knows what to do in terms of logistics and take some decisions. Okay. So the second point that I would like to talk about here is the optimal site layout location for the tower crane. What we took into account was the two main objectives. Where is the location of the tower crane and where is the location of the truck? And not only the location of the truck, the direction of the truck. Because when you carry the module like this, you don't want the module to swing on the air, and you'd like to reduce the amount of turning, because when you come to the allocation or alignment of the module, you need some people on the ground in order to help. So we would like to reduce also the number of people on the ground, and this is what we did another research on that. So we take that into account. Also, three main goals: safety, minimize or maximize safety, and maximize productivity with minimum time, and also optimal direction of trucks. And it actually is supported by many models. Here is a case study where we have 5 towers, and each one of them is 17 floors. And we looked at, you see the gray area is the location of the truck that was selected by the contractor. So we took this and we did our optimization for where is the location of the crane. As you can see, the crane was located over here, and also the location of the truck. And we find out that the optimum location is the yellow one. So this was the solution. We presented also this to the contractor, and he agrees with us. You can see the objective is actually achieve less collision, percentage of 80% more better than the original selection that was done actually by the contract. The operation also time decreased by 38% with our model as opposed to the contractor model. And the rotation of the modules, because of the track direction or alignment or orientation, it also saves 26%. So this was actually very good modules that we developed, and we are in the process now of adding artificial intelligence to this to make it more generative, where we can make it more attractive and be used by the industry. In fact, this is how the different location for different buildings and the answer of the questions. And this was actually awarded awards actually across Hong Kong and Canada. I'm sorry, and China. So it was the second place in Hong Kong and also across big China, most of the universities innovations, and took a lot of prizes. Okay, real-time crane safety. When we look at that, we can find here all these are most of the available sensors that can be used for a crane in order to be able to work in a safe way. Safe for tilting or overturning, or safety from collision, or safety from the loading, and safety for a lot of safety issues that we look at. And we are in the process of developing an AI IoT integrated tool in order to make the operation for the operator very safe. Until now, we are trying to help the operator while he is or she is available on the cabin on the tower crane. But after a while, we'll bring him or her down with semi-automation, and then afterwards it will be autonomous. And this is what we are working on right now. These are two tower cranes in our lab that we are doing some research on in order to check the safety and others. We have different sensors. And here is one of the, anyway, this is a video because it will take time. We don't want to waste time for this. This video shows that two tower cranes, when they approach each other, then the module will stop if they are closer to each other in a specific location. So Professor Al-Haj actually saw these models when he was visiting Hong Kong. Okay, now auto module lifting, I'm gonna go fast on this because there's a lot of simulations on how can we optimize the cycle time of the crane carrying the non-stationary modules. So we did a lot of work on this. You take into account the wind load, different wind speeds, and also weather conditions, climate conditions, and many other aspects related to the operator as well. This is also another video that shows the alignment. You can see here this is a concrete module and one of the projects. And these concrete modules, you can find some people on the ground that are helping. We are trying to make this alignment automated. We using some technology, using some laser pins and receivers, and also some of the computer vision. This one also another video for computer vision, but I don't want to make the video right now because it will take some time. So for computer vision that we used actually to check the alignment, and we make this. And I have also another PhD student who's working on developing models and technology to make this alignment easier and faster and precise with less number of people on the ground in order to save money. This is also the automation of or semi-automation for the tower crane. Let me show that this video will work or not. Skip it. So this was to you the reality and also the controlling. This is working autonomous for now on the simulation. So we developed all the control algorithms to control the load without any collision and with respecting all the obstacles on the ground and any blind areas that the person can see. And then after a while, we're going to implement this to the tower cranes that we have. Okay. So the last point, which I would like also to show you here, is a life cycle module for health monitoring. And you can see those two sensors we developed in-house. Those two sensors, the guy actually working for 1 year now, developing these two sensors that work with Wi-Fi, work with solar energy when you transport the modules. And these modules will be actually, with these sensors, will be attached to the corners of the modules in order to check any fatigue or any damage or any problems that happen during transportation. So after you make sure that everything is okay during transportation and the installation, we can use these sensors as well for structural health monitoring during the operation of the building or whatever this project is. Okay, these are so this is what we developed, and it shows you also some that he is working with. You can see on the screen that whenever there are some tilting or any problems or any vibration on the modules while it is transported, you can see on the computer with the sensor. So these sensors, we built them in-house. We built around 100 of them right now. So we are just in the process of applying them to a real. We tried them in the lab and they're working fine. We're only in the process of making this prototype available for the market. The last point which I would like to discuss with you today is also some automated tools of interpreting the results of technologies. GBR stands for georadar, in French georadar, or ground penetrating radar. We use this technology to assess or inspect bridges or concrete structures. Usually we'll have a slab like this, and if there are some corrosion in the steel, you don't know anything about it until it starts to make delamination. And delamination means some cracks inside the concrete you don't see. Then after a while it will propagate because corrosion, once started, it will not stop. Propagate with corrosion, it becomes swelling, and then sometimes the concrete falls down. So this will be very late if you would like to do any problem, any remedial actions. So GBR will be used like similar to CT scan or MRI or X-rays. So we make X-rays for concrete using GBR to check the corrosiveness, or use also infrared tomography to check the delamination. So we use that actually to check and to test that on bridges. We did in many places. And in order to automate this process, usually as you can see, the guy will be using the GBR or a cart like this and then push it. Some of them also can be carried on a truck. So we bought already a truck. And we have two types of GBR also to inspect bridges and inspect pavement as well.
No.
Only 2 minutes.
The guys in the Zoom, they would like that you use the make of. I'm sorry for that. There's a lot of person in the Zoom.
Okay. Okay. So you did not tell me from the beginning.
No problem.
Sorry for you guys. Okay. So instead of making it actually manual like that, so we think about making robotics. So we developed this robot also from A to Z. We generated from the beginning. So we brought the main frame and the wires and the tires from China, and then we built 3 stories, as you can see here. It has a GPS, it has 2 LiDAR systems. It has also a 360 camera. It has also a depth camera. And we are planning to put infrared thermography and some other technologies on this GBR, on this robot, in order for the robot actually to inspect bridges without us actually interfering. And this will be a bit faster and safe. So we did that actually in a bridge in Hong Kong. And let me show you how it is autonomous right now. So we developed it fully working autonomous. I show it to Professor Labhaj. Actually, I've seen the robot. So this works autonomous right now without, the dog was working with a remote. This is working autonomous without a remote. Okay. So it can see the places, any obstacle, and then maneuver and then adjust, as you can see. So it carries a GBR, and then you collect the information. It uses LiDAR to develop the 3D. So I'm sorry for interfering with your work. Okay. So yes, complimenting us. So we use the LiDAR to just develop the 3D environment, and then afterwards we work our work over there. Yeah, it was our pleasure, yes. Okay. So this actually robot is ready right now. We are going to try it maybe in a week or two in a project in Hong Kong. Okay. We have used this actually in Bridge. So it goes, as you can see, the robot was actually running beside the cones and building the 3D environment before making the inspection. So it goes one time to build the 3D environment in order for us to identify whenever we have a problem, where is it located, to make some reference. So it builds a 3D environment, as you can see here it is built. Then afterwards we can go ahead and do the inspection. Okay. What the inspection will produce. So this is only one chart from hundreds of charts like this. This is a bridge we did in Canada. So this bridge was, the Quebec government was trying actually to demolish the bridge. And then we took it as a test bed. Then we scanned it a couple of times before demolishment. And then we scan it after new construction, and we compare in order to test our method. Then the method was perfect. It gives us, as you can see here, the red zone here means corroded area. So you can see the scale, the severely corroded area, moderately, mildly, and also sound concrete. So this will help you a lot. We build something like that. So we take all the information from the GBR, we build this. What is in between? A lot of work, and then we can discuss it later if you have any questions on this. Okay. So we validated this method actually. We're using cores and using a lot. We have a lot of validation tools for that. So this is what we developed based on the robot work. With that, I would like just to conclude here that we developed some areas that is related to Industry 4.0 or Construction 2.0 or 4.0 as well. So these areas are automating decision-making tools. In order for the decision maker, will make it faster, precise, and economic. And this is what we've done in all of the 5 areas that I would like to present today. But I will be happy actually to answer any of your questions for others as well. Thank you.
Thank you. We can have a couple of questions, please. So can you present yourself in the beginning, and then you can ask the question, please.
I'm Rudi Shriki. I'm architect and BIM manager. I'm asking for the models if they are smart.
Smart.
Yes.
Okay.
There is need to be smart.
These are good questions. Okay. The models, which type of model? We talked about many models in all of this. Most of them, what's my philosophy? My philosophy is I don't want to make models and thesis and PhD or master or anything and then put it on the shelf. So my philosophy is to find solutions to the industry right away. You can take the solution and work on it. And also my philosophy is to use the available technology in the market and then develop strong decision-making tools out of them. So when you say smart, which depends on sensors and technologies, is that what you mean by smart? Okay. So yes, the short answer is yes, because we use the sensors and technology to give us some information instead of visual inspection or some other manual tools. And then we come up with a decision making using these technologies. So most of our models, maybe all of them, depends on technology outputs. So they are smart. That
Thank
answer your
you.
question?
Yes. Another question?
Thank you, Professor, for this nice presentation, a lot of innovation. I have a question about smart logistic. It's a very important question, and I have been working on smart logistic, smart transportation.
Yes.
Here in your case, we don't have any transformation of the objects during the journey. Yeah. My question is that could you integrate in the future a transformation of your objects? It can give a case. Sometimes we have different components from different area.
Yes.
Then the question that they can convert to one area, make the transformation, and after continue our journey. And the question that where is the optimum location of this area of convergence, or taking into consideration in a transformation during the journey?
Yes.
Is it clear, my question?
Yeah, I understand. You're talking about here transformation here, because transformation has different meanings. So you mean in order for you to transport the modules, for example, from okay, let me tell you what happened. In China, they brought the modules using trucks, and these trucks will take the module in a storage area. Then they transport it to, because they have to go to the custom. Then transport it to another truck that will go into Hong Kong, for example. So yes, I agree with you. This is available. We build also something called blockchain. And blockchain here, you have many stakeholders who are working on the same module until the module will be transported to the with a digital twin as well to the site. So if you'd like to say that, yes, this is open. We did some solution for that, but it is also open to other solutions and integrate others as well. So the blockchain will integrate all the other stakeholders. So you have architect, you have designer, you have transporter, you have supplier. Yeah, all of them are connected through the blockchain.
So let's look at the optimization of eventual storage.
No, oh, you mean the location of the storage? Okay, I agree with you. No, we did. I agree with you. I agree with you. We optimize the route. We optimize also because they use one storage area in several places in Hong Kong, but we do not select because this will be based on whatever is available. But it can be, yes, it's for sure. It will be added as well. Yes.
Great. Another question? So I would like to thank Professor Tariq Zaid for his excellent presentation. The last presentation of today will be given by Professor Mohammed Hussein from the University of Alberta. And the talk is for you, and you can present yourself a little bit. And thank you for your coming here from Edmonton. Thank you.
Well, thank you. Thanks for the invitation, and thank you for the opportunity to come and speak to you. My name is Mohammed Al Hussein. I am a professor at the University of Alberta, but I know one thing in my life. I do nothing but modular or off-site construction, so nothing else. That's all I know. So there is something called CO2 in my title here, which is how I can contribute. Construction has potential of contributing to the CO2, which is environmentally unfriendly enough when you look at it. But also I'll present to you probably two things today. One is a product, which is precast concrete. So I start to look at the concrete and look back at compare concrete with steel. And I put in front of you here the I-beam. The I-beam is an efficient design. We put the material where it needed. So if I need a flange to carry some load, or I need the web to carry different load. So there is no much of waste if you look at the design of the concrete, of the precast, of the steel element. Now, the concrete industry start to learn the same thing. Well, okay, well, if the steel work this way, we start building bridges the same way. We call it University of Nebraska Bridge. And that bridge, if you look at it, is really elegant and design-wise, does not use a lot of concrete, because the concrete in the middle here is really filler, doesn't do anything. You need the concrete where your rebar is, because they can work together as a member. And then the industry starts to think otherwise. Okay, well, we have what they call it the double T. If you want to have a good span, you put your rebar in a location, and then the rest of the concrete, anything concrete in the middle, is really wasted. It's just waste. There is no need and doesn't do anything. What the concrete work is around the rebar, around that structure. So having that in mind, I start to look at how we build. So when I look at a slab of a high-rise building, we start to design it to withstand some of the forces, which is deflection, bending, and other forces. And then based on that, we determine what type of concrete we need and what type of reinforcement to carry what load we needed. And reinforcement means the steel or the rebar in the structure. So the rebar will put it in the bottom and will give it enough height. So will be a distance between the rebar and the neutral axle so I can carry the load and then surround it with concrete to carry the structure. But compared to the steel, we fill it all with concrete because of simplicity. Forming is very expensive to form for concrete. So form work costs a lot of money and create a lot of waste. So for simplicity, we just put forming and we'll pour concrete everywhere. So we don't really care as much in reality. And if you look at the concrete structure, the cost and the material and the waste, which is substantial amount of that goes outside of the concrete itself, forming and other system. In addition, the slab is designed to carry the load of the people, but it's also designed to take advantage of putting the mechanical and electrical system under that. So once you have the slab, and all of a sudden we suspend the ceiling, and we add mechanical systems and to hang this mechanical system in the floor. So the industry said, okay, well, we can reduce the concrete and we come with a system called waffle system. It's similar to the Belgian waffle, but it's a waffle system. Again, it did reduce dramatically the concrete because the wasted concrete was taken away. The waffle concrete has a challenge because it's not easy to make it because you have to make forming system and it's not cheap and expensive and it takes a lot of time too. In addition, the waffle system did not solve the issue with the mechanical structure. So if you look at these, by the way, I met two girls from Brazil. So these photos are from Sao Paulo. So you get the waffle system, and then you have to put under that your mechanical system. So it did help some, but not all what I wanted the concrete to do. We all familiar with the sandwich panel for walls. And the sandwich panel was created probably 90 to 100 years ago. Concrete, layer of insulation, layer of concrete. And all the industry was talking about this and let's fix it, let's make it more efficient. And we never thought about the product itself to interrogate, this is the right way to do it. So it's become very expensive when it comes to have machines. So to build a factory using the sandwich panel, you may have to consider 20, 30, and $50 million or euros to have a really good, decent factory. So everybody was looking around how to make that efficient and forget about the product itself, whether it's the right product to use. Connections, issues. I took these pictures from China. And then you have to connect these panels. You can see the rebars sticking out, and then you put fresh concrete in some locations. But in reality, most of the concrete there is waste. If you look at the system, the double T, the I-beam as a steel, I was inspired by that, and then I created something. I built my own system, which is a rib structure. So I'll show you that system. The rib structure is really inspired by wood. In Canada, we build lots of wood structure. And the wood is really using what they call studs in the walls and sheathing from outside. And you build the house 2, 3, and 4-story. Now we allow 5-story building. You get kids dancing in the house and pianos sitting in there. And so it's a very elegant design. So I got inspired by the wood and designed a system which is all concrete rather than wood, which I call it 3I. 3I means intelligent, integrated, and a little bit more of I's. So now the forming system is expensive. Concrete has a challenge with forming system is expensive. So I use styrofoam. I build a machine to cut the form the way I want it. The second challenge I discover is the concrete itself. So we use the regular concrete, and you have to compact it, you have to vibrate it to get it between because my ribs, I call them ribs, are tiny. So, and it took a long time. So I use what they call it SCC, self-consolidated or self-level concrete, we call it. a little bit expensive, but I can, so my target, if you look at these panels, my target is 10 minutes now. It used to take about 2 hours to pour a table like this. Now my target is 10 minutes. So I'm start to target 10 minutes or less. So I have 2 people, except concrete, I need 4. So 10 minutes for the forming, 10 minutes for the styrofoam, 10 minutes on tag time. So I can build these panels in 10-minute cycles because of the system I created, which is the styrofoam, and also the type of concrete I use. And the other things give me an opportunity to add values to the wall. So I can put stamping, give it the color the customer want, and the type of finishing the customer want at almost really very, very minimal cost. So if you can see these panels, I start basements in Canada and then start moving up to building buildings and residential buildings. And I made commitment to build the buildings at the cost of wood. Wood is very cheap in Canada. So construction in wood, so I'm building the same cost. In Canada, we use concrete in the basement, but the basement is 25 or 8 inches thick. And my wall is 2-inch thick. But I have the rib structure that carries the load. So the amount of concrete I save in the basement, I can build the entire house with no extra concrete. So the same, but I saved the wood, I saved the other product out there. So this is what it looks like. And then in Canada, we focus a lot on the insulation because of the cold in winter. So if you look at the system, all that is concrete. I'll see if my mouse, I can find it somewhere. Okay. Here we go. So this is my concrete, which is 5 centimeters. And these are the structure that carries the load, which is become multiple beam or multi-joist, if you want to look at it. And then this is the styrofoam that covers the entire structure. And then the customers can add more insulation as they go. So it's a very simple system. And the simplicity of that is the way I build it in the factory. And the other issues with that is I can create a full span. Economically, I can do a span of about 25 to 30 feet, which is about 8 to 9 meters depth or span, without having to have a teleboss in the middle. And also, it's if you look at the rib structure, where I can put mechanical system. So in my mechanical system now, I hide it between the ribs I have. The challenge I face with the thermal bridging in Canada is a very big issue because when the cold outside, that cold can propagate through the concrete. So we come up with a good system. So I implemented a system. I probably yet to patent it. So I recess the top plate of the wall with the thickness of the floor, and then I have insulation continuous. We have 2 systems. We call it a balloon structure, which means your insulation is continuous, or a platform structure, which your insulation is. So I use almost a mimic a balloon structure in my system. So if you can see the connection between walls and floors, there is insulations and thermal bridging break in the entire process. I also come up with ideas like once you're in the factory, you start innovations. Innovation about a door or window. Whenever you have a door or window, I created a beam above, a beam below the window. My window is 100% structurally solid in a way that even the house could move. The window will never have big windows. We tend to see cracks in the windows if it's not really properly done because of some movement and motion. And that's basically what it's showing you here. So the mechanical system, instead of being using the space, my mechanical system is housed between the ribs, almost most of it, really 70 or 80% of it. So this is the, unlike hollow core or other system, it really provide a room for, and then give the same structure. Even the structure I have, it is for the walls I built probably 4 or 5 times more strength. And the reason I have to add more because I have to tilt it and ship it. So my design is really for basic design is very little I need for reinforcement, but because of tilting and lifting and moving with that, so I have to add way more reinforcement. So the concrete I use reach a very high strength. In Canada, we average about 32 MPa after 27 days. my concrete, I reach 50 to 70 to 60 MBA in 7 days. So then the concrete continue to mature as you go. So these are some of the houses we start building, and unlike the waffle system and other, it really created multiple things to reduce the concrete and also provide simplicity and carry some of the items that will take away the space in the house or in the building. So these are, you can see here, the mechanical system. In Canada, we use forced air to heat, and that forced air required larger ducting system. And if you can come to the basements in Canada, you can see duct everywhere. So this way I can put it elegantly and use the space and so on. So that's the system. You ship it, and I am able to ship. The panel has, I can call it ductility, although concrete doesn't allow ductility. But because of the structure the way it is, it did work well for me. So I'm shipping those 100 or 1,000 or 2,000 kilometers away from where the factory is. And it's been, it worked very well. And you can see here this panel is stamped based on the requirement of the customer. So they sent me what they want. And I have an artist from town, and the artist reverse what the client want. We create a stamp, and we can apply that stamp on top. So any architect can come up with an idea, and that's what we do for the customers as we go. There is a system done here in Spain, but they make it as volumetric. So the Spanish company, they put the rib from the outside, and they build lots in France as well. They have lots of projects in France, but based on the modular, on the system, which is volumetric rather than 2D. I do only panels. So this is the type of project. But they patented the way they build it. So they patented that in a way that to make it volumetric, because people worry when it comes to precast about the connections and the joints. So the joints, you need to really master that properly. Connection can be engineered, which is easy to do. Everybody can do that, which is not hard. But the joints, you have to rely on the workmanship. So they pour the concrete in the walls, and they flip the walls, and then pour concrete in the floor, become one volumetric, will become one monolithic structure. So this technology is patented by this company in Spain. So that's the project about precast. And Professor Lafarge asked me to talk about modular, which is the area all I do. So I'll talk about a little bit of that as well. I'll start with so the sound. I don't know what happened, so the sound is not there. So it tells you, I'll show you here a project which is Professor Zayed mentioned. I was asked to build 5 student dormitories in the US, and they want to build 5 in one summer. So they give me to build 3 in one summer, and they give me 3 weeks for the 3 buildings. When I visited the site, I noticed there is a place I can put the roof. The key was the roof. So I end up really building 5 of these buildings, which is 3-story each in 10 days, because these models came ready from Pennsylvania to Penn State, and it was done really efficiently. And after me, the general contractor finished the project before the end of the summer. So we started in May when the school is over, and by the time the student came back, 5 buildings were up for them. So this is how the models came, and this was a little bit of challenge because it's an island town in Pennsylvania. The entire town is a brick. Every house is a brick, and they want to have the same style. So the university sent us the architect and few people to see. We built several walls to show them. They did choose the pattern. So the bricks was built in the factory. So those modules were shipped with almost complete air conditioning installed. Flooring is installed, except the connection between the models, which they have to do afterwards. The key, if you look at the presentations today, Ismail, about the modules and the information. So if you front load the model, I know Dr. Zayed mentioned about the logistics on site. So a couple of things when it comes to installing modules. The schedule is no longer days, because in construction, we're familiar with days. We schedule everything in days and weeks. Here, my schedule in minutes. So if you look at the the calculations. Every task here takes seconds and minutes. And then I have to locate the people in locations that when I want them, I find them. So everybody will do 5 minutes or 2 minutes work and then wait for another 10, 15 minutes, do nothing. The problem, they start blowing around and multitasking. They're talking what they want to do on the weekend and so on. When I want them, I can't find them. So I said, no, you stay here and you do 2 minutes. You stay for 10, 15 minutes for the next module when it comes. And then I have to schedule everybody based on the trades, based on the specialities and the locations, and they have to work less. So at the end of the day, 8 hours shift, they would do probably 60 to 70 minutes maximum worth of work. But they do the entire work I wanted to. So it took a while for the industry to understand, to live with me on that, in that type of schedule, because really everything in minutes. There is nothing text. So I had to build 16 modules per day. Every half an hour, a model to be completed, and each model has certain tasks. Each task will be done within minutes. So that's how the schedule will be. So if I take you back to the factory itself, in North America, this is for wood industry. So they do a lot of conventional under the roof. So they do this, like that machine you see here. I ask, they make the rim board of the house, which is the end, out of smaller pieces, which is 2.5 meters long, and they will make 15 or 20 meter long. And they adjust them together. So that machine has been in the house for about, in that factory, about 45 years or 50 years as well. So but it's doing the job. And then when they put it together, you can imagine how much waste of time. So what I put for you, these are principles of lean. I know there's a lot of discussion about lean. So motion, transportation, defects, overproduction, weight. So it's all violated. And they do violate that every single day. So then this person has to go, or few people, they have to go and pick up the material back and forth all the time. And when they're done with that, then they have to fasten these two together. So if somebody will come with the nail gun, you can see that guy is walking. Like I made that animation because as a university professor, we are not allowed to take videos and photos. They don't allow us to do that. So we have to translate that into a visual kind of system, which is so this guy move up and down. But there is good thing about it because he doesn't need to pay membership fee for gym because he's exercising every day. So I look at it and said, okay, well, let's see, fragment it into smaller pieces. What can I do to help this industry to change the way they do things without having to invest in technology? I moved the machine, the one you see from the top left, I move it to where he needs it. And this company, they told me they saved 4,200 hours per year just moving that machine from where it was to where it was supposed to be. It's just as simple as you can see that. So now nobody's moving back to pick up, and then we use the locations ways in front of the operator, so it doesn't have to travel back and forth for all these pieces. When it comes to the joist, I use the gravity to the advantage. I can load those on top and just lower it down, then going to work. We count the work 2,000 steps on average per floor. Now all these steps are like just standing in one location and no automation. If you look at that, very, very little automation. We start to push hard for some in advance work. If you look at these joists are pre-drilled in advance rather than drilling on location. You can see the top part, people move up and down. You can really co-locate the material to be in a comfortable place where the workers can reach out and put it together. And very little technology, you can really do things, remove the demand on the physical demand on the human. So instead of you climbing up and down all day, so you can take a little bit advantage of the technology to help you do some of the work. And installing drywalls and the rest of it. So this could go on until like to finish the operations that needed. The concept I push hard in this industry, two things: fix the people, fix the tools, and let the product come. So as a manager, that's what your job, to bring the product to the tool and to the human. If the human moves and the tool moves, then you're losing money. So what can you do to fix the tool, fix the human? And again, in Canada, we build with wood construction, so they tend to build every wall separately. And if you look at the house, has lots of walls. So the students, when they look at that, they said, well, if I can build the exterior walls on one big piece, why don't we build the interior walls together to make one big wall? So today, we build all the walls together. We ship them as long as the truck can carry. Like the truck can carry 14, 15-meter long walls. So I'll have 5 or 6 or 10 walls. And then one side, we cut them eventually. In the factory, I started in the beginning to look at the same thing, the way they think, okay, let me build it, and then people move back and forth. But if you look at that, I have what they call it the lean concept in the top here left. It shows you the activities and the tag time. So around, I'm trying to find my mouse again. So these are activities which should be done by station, and each station will have a certain number of activities should be finished. But what I discovered that people have to move back and forth. There's lots of motion waste and lots of transportation, I call it people. So I move away from that, and I start to build more walls first, and then you put in a volumetric model. What I discovered also, the industry in North America need a little bit of automation. I know construction doesn't like automation. They get scared. The same way we all get scared from the dog walking around us here. So the industry has got scared really from automation. So I start to build my own machines for framing. This is for wood framing. And these machines fully automate, in a way, not fully, I mean like with the human in mind. You have an interaction with the human. I build all the walls in a 2-story house, all the walls, interior and exterior, between 60 to 90 minutes. So, but the material is there. So the material coming to you, and the human, you just put it in place, and the rest was done by the machine. So these machines are fully developed, and I'll put it in the market hopefully this summer. I was supposed to put that a couple of years ago, but COVID, and then I opened the precast factory, so I spent more time in that, so I put it on the shelf. But nowadays, this summer, hopefully we'll probably try to commercialize that. And I also built one for light gauge steel, which is popular in multi-story building, office building, commercial buildings. So we use steel rather than wood. And I built a similar machine to do that kind of operation to frame the walls in the. So this was built in one location in the lab. Now I move it to where the precast company I have. So the same thing, this machine is really ready to go for the market. And that shows the machine, the way it operates. And it was developed by students primarily. I hire co-op students from high school, from university, and supervised by master's and PhD students. So this was developed. They will design, they will buy, and they will build it for me. And we test it all the time with the students. The wood framing, shows you, if you look at the human here, he works in a very small area. His motions are within a meter and a half max. Pick up something, drop it, pick up something and drop it. And that's what I'm saying, you can build a house in 60 minutes or to 90 minutes based on the size of the house. Once that, here you can see lots of interaction between the human and the machine. There are other machines where you have way more machine work rather than human. Other places you have 100% human. In this case, the windows, I budget installation of a window 6 minutes. Every window must be installed in 6 minutes. 6 minutes, 2 people. One will carry it using the vacuum system and put it, and the other will just finish it up. And so on and so forth. So there's a lots of efficiency in place you can gain. And the other project which came as needed is mechanical systems in hospitals. So this project, we put in the corridor all mechanical system and branch out into the rooms, the patient's room. These models you can see in the top left side will be built in stations of 2 hours. Every 2 hours they have to move, and 3 stations. But what demanded is everything must be ready for that person to put it together. Nobody's making anything here. It's only assembly station. And we start to look at on site, the same thing. I have people fixed in one location, modules comes to them, and then they have to do certain operations and wait for the next load of the next model to come. So these people here sitting and standing, because they give me, I think at the time they will give me 3 floors at a time. So when they build 3 floors, and then they give me 3 floors, my modules will be ready, staged in a location, and then they move in to start putting them on the 3 floors they give me a schedule. We come up with systems to hang it from distance because I can't slide it in, but we have a platform which is extended a little bit to the outside, so I can slide it in. Lots of technologies we use from other technologies, adapted, and so on and so forth. So this is basically what this project is all about, mechanical systems. And the last is just to show you, this is a 34-story in Brooklyn, in New York, which is, again, I had the same challenges as Hong Kong. I have to find a staging area. If you look at these people, they sit in one location. If you look at the bottom, every person is counted for based on what they do, what kind of operation they need to do, and when they do what they need to do, and schedule basically, because these people will be doing something, sit down, and don't go anywhere. Stay where you are. The next model will come to you. With this, Professor Lafarge, I done my presentation.
So much, Professor Mohammed. We have a couple of questions, please, and then we will move to a table round table, please.
My question is about the storage zone. It's be huge of the building, or how you do if it's a small plot.
This one here, the one you see in Brooklyn, was probably the busiest street in Brooklyn. There is no way I can block the street for an extended period of time. So we found a parking nearby. We'll store our modules in nearby, and then we'll transport them one by one. If you can see here, the animation shows how busy the street based on the information we receive from the cameras. It tells you how busy the street is. So we have to, so I have really zero place. So I have a challenge. It's a challenge which Dr. Zaid mentioned earlier on. To find a location for your models, you have to plan, like way more planning than regular construction, really. Yeah.
So now we have some question for our keynotes here present. So we are happy to share with you. So any question, Mrs. Asia, she will be on. I will be on the floor to make the moderation, and Asia can, if you have any question, you can raise only your hand, and Asia will be nearby, and you can ask your question, please. Yeah, can you present yourself in the same time? Can you stand up, please, Wasim? Dr. Wasim.
Yeah. Wasim is good. Hello, everyone. This is Wasim Balkhi. I'm a doctor in civil engineering. I did my PhD under the supervision of Professor Lafarge, and I'm now doing my postdoc also under his supervision. My question is for Professor Muhammad and for Professor Tariq. The same question we noticed for modular construction. Two kind of buildings, let's say. One of them is the high-rise buildings or the large buildings, and the other is a little bit more customized or more small-scale buildings. So the question is, how do you deal with the flexibility of design in the architectural design when you do the modular construction?
Thank you.
Thank you. I'll tell you from experience. When I was approached by the company to build the 5-story in New York, in Pennsylvania, I was hired by the factory. And then they brought in lots of people similar to this room. There were about 45, 50 people in the room. And we have the same thing. They said, well, Professor, we will have a problem with mechanical system, problem with connection. And they were making jokes as well. Well, the bricks will fall in the road, and they were nasty. But many, they said, well, modular is not good because architect will not like modular, will prevent them from innovations and so on and so forth. And I I have two students with me and we write the questions. So I went to the factory, I brought in the mechanical, the plumbing engineer, like the bricklayers to ask questions. And then after lunch, a fellow came, tall guy with bald head. He said, can I have a couple of words? I said, sure. I have 67 questions, 67 problems to address. Give me one more or two. I was ready to leave, really. And he stood in front of everybody. He asked one question. He said, some of you mentioned that the architect get annoyed by modular, and the modular will not prevent them from thinking and prevent them from creativity. How many in the room agree with that? And can you ask him, can you stand up? And I had probably half of the room were up, standing up. And he said, okay, those who are standing up, if you are an architect, stay up. Mm-hmm. And all of a sudden, everybody says, so none of them was an architect. And he said, I am an architect, and I don't get annoyed by technology. I can create, I be creative. And then he said, the floor is yours, professors.
Problem solved.
Yeah. So anyways, sometimes we speak on behalf of others. We speak on behalf of others. The bricklayer person, he said, I can put you this brick on these walls and I can ship it to Mars. I said, I don't want to ship it to Mars. I want to ship it. So anyways, we speak on behalf of others, which we don't know. Those who are experienced architects, experienced mechanical trades, they know how to solve any problem, in my view. They don't have to come to me for a solution.
Thank you.
Okay.
Please, you can.
Okay.
It's for you.
Thank you for the question. The question is very important. And one of the drawbacks of modular that we read in many literature, it's called design freeze. Design freeze means you are going to be, because you are looking at it from the manufacturer perspective. A factory would like to manufacture a book or a can,
Product.
Pepsi can or Coca-Cola can. You would like to make all of them similar in order to be able to produce more and to approach many people and to get less cost, less time, blah, 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 all these kind of things. So they said, okay, the design will not be too many designs available for modular because you cannot actually do all the designs as you wish, which makes sense from the architecture point of view that you are not going to be flexible. Yes, this is part of it. It can be a problem. It can be, to be realistic. However, with evolution, with time, with thinking from everybody in the domain, to do stuff in a way, paying attention to that this will be a modular, for example, the architecture, if the architect will think about it, that this will be modules. Then you design your design based on the construction or the installation or the manufacturing. I think new ideas will come,
For sure.
and things will be better. So yes, it apparently feel that it will be closed or is not going to be a problem. Maybe, but this is a maybe. But at the same time, with time, I think things will be solved.
Thank you. If you have any question, you can even give your question in French. No problem for that.
Thank you for the presentation of all of this technology, which is really fantastic, interesting, effective. My question, if we look to the developing countries, where is today the main demographic growth, we have really need of massive construction, or another case which is really interesting, the post-disaster reconstruction. It could be related to the natural disaster or to the war. One of the questions which we have about Gaza, tomorrow, how we can reconstruct in very short time. Then this technology could be really fantastic, could be very interesting. Then my question is that, what do you think about this perspective of the use of this technology in this situation, developing countries, post-disaster reconstruction? Because in all of this area, we have a lot of difficulties. One of the difficulties, we don't have the capacity building. And with this, it could help. Quality control, it could help, and so on. And one of the questions also which we have was about the use of local material. Because also it's very important. We don't have this noble material sometimes for sustainability. Then if you have any insights about this, I'm really very interested.
Thank you, Sam, for your question. We can add even, we can speak about high tech and low tech in the same time, if there is any answer for that. Please, Mohammed, or
Yeah, well,
please.
for the question is resiliency, because when you start looking at disaster, we need to build with resiliency in mind. Now, I start to question whether, like, if a hurricane hit a town, or earthquake, which we have to see, we start seeing that flood and fire and so on and so forth. So as towns, none of them are 100% resilient, because we all want to be close to the ocean. We all want to be close to the mountain where the fire could be. But I'm looking at the factory. With the factory creating resiliency, can I rebuild the factory fast enough that I can build the town itself? Like, I don't have to go outside of the town. So to answer your question, and I'm trying to tell you, I have a feeling modular could be a good segue with resiliency in mind. Even if the factory is destroyed with the rest of the town, but you can bring back that factory if it's low-tech factory much quicker than, and then they can start producing places. Yeah, again.
Okay. My thoughts about that, and this happens actually to me after the earthquake in Turkey, and it was a lot of disasters all over the place. I called one of my Turkey friends, and I told them, okay, I have a very neat idea where we can make modular, or if it doesn't have to be totally modular, you can have at least the panels or each wall, or maybe bathrooms or things like that to be manufactured in the factory, and then you can transport, and this will be for sure easier and faster, for sure. But the biggest and largest problem was the debris. How would you get rid of it? And how would you clean first before you start modeling or reconstructing again? It happens also in Katrina and the US, or New Orleans and other places where also same thing. When you have a big tsunami that happens, and then how can you rebuild and remodel again? For sure, this method will be good and effective, but it needs, as I said, the resources.
Yes.
How would you do that, and how would you plan the resources as well? In terms of the material, the existing material, yes, existing material, because in North America, they like wood, they have wood, then you can make everything in wood. In Middle East and other places, you have concrete, you can make things for concrete or others. Yeah.
Yes, thank you. Only to add to these thoughts, there is something more than resiliency, and resiliency is very important, and what you said is really interesting. There is something else that we can add is regeneration of something which is done. Regeneration, it can be done for something new, but it can be done when there is a disaster or something, or disaster or a war or something like that. And then to build a new strategy for new cities, we have to build now with kind of as skills as the adaptation to with resilience and with regeneration for the climate change, and for some risks as the terrorist attack or war or earthquakes. And this is really now what we call it as the durability indicator for the future. And I think, as you, that new technology with new skills and with this new information can help to be more quicker, because the time is very important, because there is emergency, and in the emergency there is some basic needs for any human. And in the beginning it is water, then it is food, then it is electricity, then it is housing, and there is some theory on that. So this is very important. As we can share with Ismail, the fact that we have BIM, it is a kind of that we have the ability to reproduce the same thing. For example, historic monument or something which is important for the country. If we have not this copy, it is very difficult to reproduce the same thing. It was done, example, here in France for La Cathédrale de Notre Dame. We was very happy because it was scanned before. Otherwise, it was not impossible to reproduce the same monument. Good. Please, can you present yourself? And
Can I have one more comment?
Please, you can, please.
One more comment regarding this. Actually, for disasters and rebuilding again, every location will be totally different. So we do not have models that fits all. So it's a model that can be adapted So you can take a model in US and Canada will be different from Europe, from Asia or whatever, based on the material, based on the possibilities, based on the availability of transportation, many things. So this should be adaptable.
My name is Dora Karmewi. I'm civil engineering doctor. It's not really a question. It's more, I'm confused because we have the two presentation which you present that we need high technologies to improve productivity for less waste and cost. And with Professor Mohammed Hussein, you just showed us we just need to work smarter and we need good manager. And we don't really need high technologies to be more productive. So the idea, do we really need high technologies to be more productive, or we just need to work smarter and work together, and that's it?
Thank you. Ismail will answer you.
From my perspective of view, the machine complement the human in all his tasks. So I think even in the presentation of Mr. Mohammed Hussein, he showed us that it is simple, but in the background, there is a work that has been done with the machine. So I think that the intelligence of the machine is so important to produce more simply tasks. So if I take the example of the BIM or the digital twin or the IoT all together, if we prove of a system of work with all the humans and we do not use the intelligence of the machine, we cannot have a smart building by the end, and we cannot even simulate the waste or zero carbon. So I think it's also 50-50. So it's important in the both cases. We should have the human simplicity and the human skills, and also couple it with machine is gonna be perfect in the future.
Thank you.
Yes.
Can you add something for Dora?
So from my perspective, you need both. And both are needed, but you have to work hard on the method first to run out of any ways to reduce time or increase productivity using the methodology, the existing system, which Dr. Hussein did. And then you also don't forget that also technology will help you. So I read actually a book maybe 30 years ago or 20 years ago about productivity, labor productivity for construction sites. And they have an engineering model. This engineering model used the method to improve productivity using the method, and also at the same time, the technology or the means, the tools. So both of them complementing each other, and both of them will increase productivity. So you work on the method, how you do stuff. You start from one step to the other. So no, why don't we make it half step and half step, or you make it overlap? Or so you think about how the methodology that Dr. Hassan was doing in his research, and then based on that also you run out of all solutions. You make the best out of this, then you add to it also the technology. It will be better and faster and more productive.
Thank you.
Yeah, well, technology goes hands in glove with the software up front, really. So you can be rich in machines, but if you don't invest enough energy on the front end, the software in particular. So I know the construction industry moved from AutoCAD, which was not a good model to start with, and then they moved to something called Revit nowadays. Revit is not designed for manufacturing, so you need to spend a lot of energy and have, if you come to see, I spent years and years, lots of money on the software to make the machine work. Otherwise, we have a lot of people, I noticed, they bought machines, they end up being rich in machines, but they could not run it because they did not spend the right time for the softwares and the integrations and all that up front. Yeah. I know the gentleman has his hands up.
Okay, thank you. Si vous pouvez vous présenter.
Est-ce que je suis bien branché? Bonjour. Alors, je m'appelle Djibi Sagnan. Je suis ingénieur en génie civil, créateur d'entreprise. Je voulais répondre à votre question, monsieur. J'ai lancé ma start-up à Station F depuis 3 mois qui s'appelle Riverlands. Et l'objectif de Riverlands, c'est justement de trouver les solutions, je vais faire après en anglais, de trouver les solutions à la reconstruction dans les plus brefs délais des villes qui ont été et qui seront détruites par les effets du changement climatique. D'accord? Donc, on nous a donné deux cas d'études. Le premier, c'est la transformation d'un camp de réfugiés au Kenya, dans lequel il y a 226 000 personnes qui y habitent et pour lequel les Nations Unies voudraient le transformer en une ville durable. Et le prochain, ça sera un camp de réfugiés en Bangladesh qui s'appelle Kutu Palong, dans lequel il y a presque 1 million de personnes et qui sera aussi transformé en ville durable. Et je voudrais vous remercier infiniment pour le workshop et votre présentation, parce que l'objet de notre présence, c'est à Ludovic et moi, c'est justement de trouver ces solutions à comment construire très, très rapidement, dans un futur très proche, les villes et les territoires de demain. On est persuadé d'une chose, c'est qu'on n'y arrivera pas sans la construction modulaire, parce qu'il s'agit de reloger des dizaines de millions de personnes. Et ben, mon objectif, c'était de venir prendre du renseignement. Je peux la faire en anglais très rapidement?
Oui, bien
Non,
sûr.
c'est pas nécessaire.
Continue, continue.
Thank you very much for this master workshop, and thank you for your fantastic presentation. My name is GB Sanyal. I'm civil engineer, and I'm also CEO from Riverlands organization. We are based in Station F in Paris. And the topic, the main goal of my company is from now to seek all the technologies we can gather so that we can predict the construction of the resettlement cities, which will host all the mass population who are forced to flee their homes after destruction in relation with climate change. So, for example, for the whole world, we are talking about 485 million people moving inside their boundaries. So it means that the resettlement is under the responsibilities of the states, because it's a foreign country, is a sovereign country, and they don't know from now how they can cope with this challenge. And we, as civil engineer and BIM engineer, we are, and also architect, because now we are 28 in the company, civil engineer, architect, and territory modeler, whatever. And we are almost completely, how do you call that, convinced that the only way to address this issue is through the modular construction. So I've been invited by Professor Lafarge, and thank you very much for that. And we are taking this direction. And to come again with the question which was asked at first, we decided first to ask our architect, there are 7, to design the best way they could how the city will look like, because we are now in Kenya, and afterwards we are moving in Bangladesh. Thank you.
Thank you so
Then
much.
after that,
Okay.
Pakistan.
Thank you so much for your testimony and your these kind of information. Yes, for sure. I will give some information. I will give some information about Station F. Station F is one of the biggest famous incubator in Paris, where there is a lot of startups, where there is a lot of facilities, which was designed. Now it is kind of 7 or 8 years, but one of the guys very well known in France, who is known as innovator guy. So it is a kind of place where innovation center. Well, there is big groups also there to see what is happening there. So thank you for your testimony. Beatrice, please.
Thank you very much. I'm Beatrice Ruse. I'm working at the Institute of Lean Construction. I have a question concerning the new technologies. If you compare with the traditional construction, what is the part of engineers and conceptual technicians? If you compare with the workers, how many workers do you need, and how many engineers do you need with your technologies?
Thank you, Beatrice. I would like to thank you so much, Beatrice, because she's involved as Ludovic, and as Dorra, and as Iman, and as Wassim, and as Slim in l'Institut Français de la Construction Lean, who are organizing this event. Please.
Well, it's a difficult question as usual. Beatrice said. Yeah, it's we look at that in terms of need versus capacity. In Canada, we start to discover that we need lots of homes to be built in a very short period of time. Whether Canada has the capacity, human capacity, to build all these homes. So they're starting to look at, so the technology will probably bring speed, which is okay. Maybe will also reduce the need for the capacity which we're looking at. So we'll create a new breed of jobs. People think modular will take away jobs, but in reality, modular open up new opportunities. Lots of new generation, they don't want to use the shovel anymore. They want to use their fingers, and that's why Ismail's job will have a lot more people for Ismail to work in his field rather than in construction. Definitely modular. I agree with the gentleman here. It's a probably a reaction or a solution. But if you look at something that pays money versus something that it's good to do, so Olympics is coming to France next year. I work very closely with a company in Brazil. We did all the Olympics needs. You can imagine a kitchen. You put a kitchen and for hundreds of athletes, and then you have to move that kitchen from one location to another location. They use helicopters. They use all kinds of the logistics was amazing. So if Olympics, because Olympics pays and modular was the solution, and the only solution was at the time. So I think to the gentleman message here, perhaps, yeah, when we are all committed, probably modular would be a solution for displacement and so on. But in terms of labor, it will be more labor upfront. That's what Ismail's kind of needs there.
Okay, so two items in this part here. The first one is related to the fact that Qatar 2022 World Cup, most of the stadiums were built using modular construction, and they will demolish them, not demolishing, I mean dismantle them, and then they will actually ship them to somewhere in Africa, or I do not know where.
A lot of spaces.
Some of them, yes. So they keep. No, they would like to get, they will, some of them will be only just for the World Cup. So it's exactly like this. So they did that. Actually, they will donate it to some other places that they need such type of stadiums. So this is one part. The other part from my perspective or my philosophy that I can understand from the modular construction in terms of labor. When you look at it, the laborers in the construction industry were working on a open environment that are impacted by weather, for example, I cannot work with a crane if there is a rain or snow or any other storms, wind. Okay? Or a strong wind or something like that. And then also laborers who are working as well in Canada, we have 6 months, we cannot work actually outdoor because of the weather conditions. So we have to develop the frame and cover the entire building, and then you can work indoor during the 6 months if you would like, unless otherwise all the labor will be actually fired during winter and then hired again during summer. So the idea here is when you go from this open concept or open environment to a closed environment where you have everybody working on the factory within a very good temperature, with a very high quality laborers working, all the tools are available around you, the machines are helping, very good controlled environment, for sure productivity will be higher. For sure you are gonna build more if you would like with the same crew of people, you are gonna build more. So yes, it will be more high quality, faster, better, and many other aspects actually, because you are going from an open environment to a closed or controlled environment.
So I agree with you, because there is even the spirit is changing from artisanal work to industrial work, and it will enhance the qualification and the quality of the worker and for the labor for sure, and it can even limit for political reason the immigration, which is it can be some problems for some region in the world, and this is really a whole vision for the human resources and for the qualification and for the condition of the worker on site or in the factory. But in the same time, we are facing more and more challenges in construction. It is we needed new technology for that. We need new technology, and we need to invest on the human skills for adaptation and for the productivity person. Me and now I am more productive with the tools that I am using than before, which is very important because there is a real invest on the human skills to the adaptation, to the regeneration, which is the word is very important, to be adaptable for these kind of skills. Do you want to add something, Ismail, or you think that you will hire more, or what do you think about that? Because you are scanning a lot of things.
Exactly. My point of view about this subject is that, especially about the human impact. Today, even with the rise of the demand of the new technologies, we still have to do to remonte in competence.
Yes.
La remonte en compétence. It's very important to have high qualified personnel to know how to use the new technologies. So as I said before, it's like 50-50, and we still need a human. And in the future, I think we will use wisely the human skills, and this is very important.
Great. Please, yes, you give the student and then Iman. You got it. Can you present yourself, please, in the beginning?
So I'm Rafael Casanova. I'm a student here at Central, and I'm doing an internship here at with Professor Lafage. And my question is also regarding the impact those transformation could have on the worker, and specifically, as you described it, it is comparable to a transition from artisanal to industry, but for construction. And do you fear that it will also have the negative impact of, for instance, the organization of work, and how increasing the rhythm and how fast each worker is expected to work could lead to a bad impact for the worker? If that's clear enough.
I know where Patrice came with her question too. Now I get, it's true. It's a real challenge. We're looking at a couple of items to see how we can prepare the industry for that. We're looking at the Industrial Revolution, the first Industrial Revolution, when people start hiring people, and then there was lots of mistakes humanity made. We start bringing children to work, extended hours work, so people didn't know better. And then all of a sudden the regulation start to come, and the industry start to learn. The government intervene with the age and number of hours to work and so on and so forth. And to Beatrice's work, really, you just mentioned somebody is happy to be working outside in the field. Now you're bringing under a roof the noise and the cultures and like the interaction. So we are not there yet, but that's the challenge on both the industry and academia to work together to see whether we can have a kind of a guideline, a framework, how to educate the manufacturers to deal with the situations. I may give you a couple of examples. My apology if it's late, but I'm extending my discussion here. My student looked at the window manufacturer, and she said women take their break waiting on the front of the washroom to use the washroom because they have way more women than regular places. And so the chairman, he said, wait a minute, okay, that's a serious problem. I didn't know anything. He didn't know anything about it. So he asked my student, she's an architect, I'll give you a voucher of $100,000. Think about a washroom for a woman. So washroom is designed probably by men. It was not designed by women. So we need to see what does it mean to have a washroom for a woman. We have to learn a lot, really, because today general contractors have a temporary relationship with all the trades. You bring the trade, you don't like him, you don't take him another time, right? But he's not yours. When we come to the factory, these people are yours. I built my own precast factory and asked a friend who has a precast factory, I told him, what is it I can learn from you? He said, human. I said, what do you mean? He said, one day, one of the workers came to tell him, listen, I have addiction issue. I'm an addict, and I use alcohol, and I'm addict. He said, I didn't know anything about it. It was passed by. I didn't want, but now I know it. What can I do? Is there a book I can read to understand? So it's a challenge. When we move to this industry, if we move 50 or 40% of this industry to become industrialized, I know you mentioned the word pace. You probably think about Charlie Chaplin movie, but again, it's a challenge. We all work together on this. Yeah, thank you.
Thank you. Iman? Iman, please.
Um, I think that there's, of course, a lot of topics and the questions here, but what I see is that the need of working in integrated teams with processes, with methodologies, with technology. And I'm afraid about something is, there's two things, okay? We all know that a fool with a tool still a fool. So we have to work on processes. We have to bring the knowledge of older teams like they did in Germany when they adopted Industry 4.0 by gathering the unions to train them to pass the le relais to new generations and learn how to work with new technologies in the industry, in the construction, etc. I have a question about all of the data we can generate in this new projects with the new processes implementing BIM and the data, because we have the need to build data centers. So if we use the data and if we produce more data to decarbonize the construction, but we need to build more data centers, for example, which today needs a lot of cooling and not a lot of concrete. So we are not solving the problem. So if we think that we are solving a problem, but generating another one, maybe we have to think about really new way of thinking.
Okay. Thank you, Iman, for this question. Iman, she's under jet lag. She's just coming 2 days ago from Canada, but her question is very clear. Thank you for that. I have some answer to share with you, but I would like to give thoughts. Ismail, have you?
Yes,
Do you want to comment?
I have two type of answers. I have the hard one and the soft one. So I will start with the hard one because it's a necessity today, especially to know if we need, how much we need that thing. How much do we need, for example, electric cars? Because if we compare France today with Germany in the production and CO2 emission of these electric cars, if you put these two examples together, we will see that Germany produce with the same manufacturing materials more CO2 than France. And why is that? It becomes political problem because the use of gas, or the problem that happened with Russia and with Ukraine. So we don't solve the problem of CO2 with electric cars in Germany more than France. So France, if you can say we have a margin of success if you compare it to Germany. So if you move on to data today is something that we need to work. And if we think about the cloud, because the cloud is storage, so we need to build buildings to store the information, because people don't have this idea of the physical place, because the data is stored in physical place. That's what we call cloud. And this is why we pay per month to have a space in that cloud. So I think it's more a question about necessity, and it's like pesé des intérêts. So there is interest here. It's more like the use of wood in construction, because the use of wood will reduce the CO2 production. This is, nobody can deny it. But also, if we are going to transport it from a country to another, it will have also an impact in our environment. So I think we don't have like a clear yes or no to this question. So it depends on what do we need. This is why even with the platform, the softwares, the platform owners, they provide you space in the cloud, and then they will tell you that they will delay your work if you don't have a copy. So I think it's kind of a solution to this problem. I would be glad to hear it.
Thank you, Ismail.
Yeah, thank you, Ismail. My 2 cents on this, actually, there is no gain without pain, right? So for sure, there are pros and cons for each solution, always. And whenever we have alternatives, there are pros and cons, pros and cons. So the problem here is we have to think about the value of cons, because you said that we're going to generate another problem when we use the data center and things like that. But is it the problem that will be generated using data centers is similar to the original problems that you solve? So you have to have the assessment means to check the impact of each one of those, which we don't have until today, unfortunately. So, or is not clear, is not in the hands of everybody. So I think it would be better to generate the assessment tools to assess the impact of each solution. Then what will be, and the impact of the solution has to be total. It's not only just to look at the solution, you look at the solution and what the solution generates as an adverse impact as well. So impact positive, we look only at the positive, which is good, but we have to look at also the little negatives that are also remaining. It will be negative on the other side. So you have to compare between solutions totally, not only from one side.
Okay, Mohammed, for you? No, for you, please. No, for you, please. Because I will finish.
No, that's a good point. Yeah, there's nothing called 100% carbon free. Even you mentioned wood. There are two sides of the story. Somebody will tell you, wait a minute, the wood, they have to harvest it and all these kind of things. So it's nothing 100% free. But again, the future, like I know Professor Lafarge is pioneering the 3D printing. I was talking to some people outside. 3D printing is not that I print a house with the 3D printing. 3D printing will change the way you think about material, concrete. The concrete will be different. If I tell you this 20 years ago, you will say, oh, will turn your head around. But nowadays, with the technology we have, everything is possible. So the possibilities are endless. I know there will be one day in my lifetime, will not be far away. We'll have lots of different things. Material sciences, in my view, is if anybody want advice to do is look at material. The future will be there. Yeah.
Thank you. I would like to agree with you, Iman, on the fact that more we use data, more we will produce energy, and energy is really the policy for each country, and this is very important. This is a fact, and we have to face these challenges. And this is even when we send an email. In fact, we thought that we are doing nothing in sending an email, or even in the fact that we don't clean our messagery. We are consuming energy, and we thought that we are very good in environment, but sending an email, it is something important when we compare it for consuming energy. There is a lot of new challenges in research on data center where they are dumped, in fact, in the sea for the consumption of the energy also. So there is a lot of research on this. It means that we are facing a very big problem, but there is a lot of research. If we compare very quickly Germany to France, and you said it very, very well, because you said that there is a transmission in Germany, but in France, because the German system is based on alternance, and the French system is based on internship, which is not the same thing. Now in France, we learned a lot from the training system in Germany, so we are more and more doing alternance in France. But in the culture, moving, as you know that better than me, to change the culture is very difficult. So French are moving better and better, learning from the transmission system in education in Germany, and the insulation in Germany are external. In France, it was internal. Now France is changing for the new building in external. So there is a lot of. In the same time, the strategy of France since many years was the nuclear energy, but Germany was not the case. So research in physics is extremely important. One of the big projects in research in physical point of view now is the fission, which is the different of the fission. The fission is nuclear, which means that you have an atom, and the atom is breaking in the middle, and you can take the energy, and this is the fission, and this is the nuclear. The fission is the opposite. You take two atoms and you bombard the atoms, and you have a fission. In the theoretical point of view, we can do the fission, but in experimental point of view, it is not yet ready in industry point of view. And one of the biggest projects is entitled ITER, is located in the south of France, but it is not French project. It is international project. All the countries knows that the most important thing that we have to work on it in the past, in the present, and even the future is the energy. So it appears that the fusion is one of the things that we are working on. Not theoretical point of view, it's okay. Experimental point of view, it is not the case yet. It seems that it will be in 2080. But since now 1 year or 2 years, 1 year and a half, the Chinese Research Council said they resolved in the laboratory for, I think, 35 seconds that the experimental point of view was done in the lab, not in the industry. 1 year before, after the Chinese, Korean Research Council said we succeed in 1 minute and 30 in the lab. So you know, research is design, lab, and then the industry. It seems that there is a lot of work. We can focus on that, and there is a lot of research in the world working on that. And I think it is one of the hope that I would like to work, and we need for that engineering. Why we need engineering more and more? It is very important to know, because in theoretical point of view, it is done, and we need now engineering capacity and talents. And when I say that the Chinese did it or Korean did it, it does not mean that they use only Chinese or Korean. I heard, I know some information about that. They take some European engineering to do it, which is very important to know. Thank you so much. If there is any question for the last question, or it is okay for all of you. So I would like to reply as much as we can our guests. And thank you so much.